Welcome to this explainer, where we're going to uncover the massive, hidden physical infrastructure that powers every text, stream, and AI prompt in our modern world. Think about it for a second. A notification sound breaks the silence. A text message goes out. A movie starts streaming. A credit card swipe is approved. Millions of these events are happening every single second, and they all depend on one incredible, invisible backbone. Most of us are never going to step foot inside one of these facilities, but today we're going behind the security fences to explore the massive machines that literally never sleep.
Okay, let's just dive right into this by asking a super simple question. When you upload a photo to the cloud, where exactly does it go? We hear the term the cloud every single day, right? We're told our emails, our family photos, and our sensitive documents are securely floating around up there. But is that really the case? Well, the truth is, the cloud isn't in the sky at all. Actually, scratch that. It's a very tangible, highly physical network of massive facilities. Instead of this weightless, invisible entity we all imagine, every online search, every social media post, and every AI-generated answer lives on physical computers inside buildings we call data centers. And we aren't just talking about a stuffy little server closet here. Some of these campuses cover millions of square feet. They operate like immense, nonstop digital factories.
Today, we are taking an exclusive guided tour to demystify this whole digital fortress. We'll start with the myth of the cloud, step inside the server room, explore power and cooling, discuss the huge AI computing boom, and finally look at the future of data.
Let's start with part one, the myth of the cloud, and shatter this illusion of the internet. You know, we tend to think of the internet as this effortless, invisible magic, but that magic requires an astonishing amount of physical engineering. We're talking thousands of miles of fiber optic cables and millions of real, humming machines working in absolute unison. The crucial takeaway here is that data centers are the beating heart of our society. If they go dark, our entire modern civilization effectively stops functioning almost instantly. We're not just talking about losing access to your favorite streaming show. Airlines wouldn't be able to fly. Emergency services would go totally silent. Hospitals, banks, governments, they would all grind to a halt. These massive buildings absolutely are the foundations of modern life. Moving on to part two, inside the server room, let's explore the physical building blocks of data. Imagine walking past the layered biometric security checks and stepping onto a data center floor the size of several football fields. The air is cool, it's highly filtered, and there's this steady roar of cooling fans that sounds a lot like a distant jet engine. Everything in this massive hall relies on the server. This is a specialized, relentlessly reliable machine built specifically to never, ever sleep, processing thousands of requests every single second. Unlike the desktop computer you might have at home that just serves you, a single server in these facilities might support millions of simultaneous users. It's packed with multi-core processors, insane amounts of high-speed memory, and redundant hardware. So if one piece fails, the machine just shrugs it off and keeps right on working. Now, what's really wild is how these individual servers are organized. They're slotted into these standardized racks, creating a perfectly structured environment. It's like a giant, high-tech puzzle. These racks stand about 2 meters tall and they stretch toward the horizon in endless, perfect rows. And in this environment, every single component is meticulously managed. Every blinking LED light, power unit, and network switch is monitored. Technicians know exactly which of the thousands of beautifully labeled cables to pull if something acts up, guaranteeing zero disruption to the network. To store all your emails, spreadsheets, and movies, these racks basically use a tag team approach, balancing two specific technologies. They pair solid-state drives, which use lightning-fast flash memory for the stuff you need to access instantly, with hard drives. The hard drives use physical spinning disks to archive absolutely massive amounts of data at a much lower cost. And all of it is replicated across multiple drives, often across entirely different data centers, just to ensure your data is never, ever lost.
All right, part 3, power, cooling, and survival. Let's look at the massive life support system keeping this all alive.
Putting thousands of incredibly powerful computers together in one room creates some intense environmental challenges. It takes some serious engineering to manage. Because at the end of the day, electricity is the lifeblood of every server. A modern hyperscale data center can easily consume 100 megawatts or more of electricity. To put that into perspective, that is enough to power tens of thousands of actual homes. It's literally a small city's worth of power going into one building. This enormous demand means they often have to be built right next to major power transmission lines. But they can't rely on the utility grid alone, because even a fraction of a second of power loss would disrupt services for millions of people. So, to survive a blackout, they've built this incredible, layered survival sequence. If the main power grid goes down, redundant systems seamlessly kick in so your Netflix stream doesn't even stutter. Within mere milliseconds, massive, uninterruptible power supply batteries instantly bridge the gap. That burst of battery power gives the enormous on-site backup generators just enough time, literally seconds, to automatically fire up. And thanks to massive on-site fuel tanks, these generators can keep the entire facility running for days on end, totally independent of the outside world.
The power is really only half the battle here. These machines generate a staggering amount of heat. Traditionally, engineers used air cooling, blasting chilled air into cold aisles and sucking the exhaust out of hot aisles. But servers are getting so dense and powerful now that we're seeing a huge shift toward liquid cooling. They're attaching cooling plates directly to the processors, or get this, they are actually submerging entire servers directly into specialized, non-conductive dielectric fluid. It absorbs the heat perfectly without short-circuiting a thing. Pretty wild, right? The ultimate holy grail for all this environmental engineering is reaching a power usage effectiveness, or PUE, of exactly 1.0. That's a perfect score. It means that every single watt of electricity pulled from the grid is going straight into computing, rather than being wasted on overhead like cooling fans or lighting. While 1.0 is the theoretical perfect score, modern hyperscale data centers are constantly striving to get as physically close to that number as possible. Which brings us to part 4, the AI computing boom, the catalyst that's changing the data center forever. For decades, this whole system just efficiently hummed along. But the sudden explosion of artificial intelligence, that has forced these digital fortresses to evolve practically overnight. Traditional internet tasks, like loading a basic web page, are handled super easily by standard CPUs. But AI is a totally different beast. When you ask an AI to write code or generate a cool image, you're triggering countless simultaneous mathematical operations. That requires massive supercomputer clusters made up of thousands of GPUs, graphics processing units, working together to crunch the numbers. So this AI boom, it's not just a software update, it is physically transforming the data center architecture. AI models contain billions, sometimes trillions of parameters. Training them means feeding them massive collections of text and images for weeks or even months of nonstop processing. The GPUs required for this consume dramatically more power and create incredible amounts of heat, completely redefining the limits of scale and driving that rapid adoption of liquid cooling we talked about earlier.
Finally, let's look at part 5, the future of data, focusing on edge computing and sustainability. With this unprecedented demand for AI and cloud services, how do these hidden factories keep growing without completely overwhelming our power grids and our planets? Well, operators are aggressively targeting sustainability. Tech companies are heavily investing in renewable energy like solar, wind, and geothermal. They're using advanced AI software to intelligently shift workloads to times when renewable energy is most abundant. And they're even literally capturing the waste heat from the servers and piping it out to warm nearby homes and communities. It's an incredible recycling loop.
And to make the internet even faster, we're actually starting to decentralize the cloud. We're building smaller edge data centers right in our own communities. Because here's the thing, not every piece of data has the time to travel thousands of miles to a giant hyperscale campus. By keeping some processing right at the edge of the network, closer to you and me, technologies that demand absolute zero delay, like self-driving cars or industrial automation, get the instant response times they need to operate safely. So, as we wrap up this explainer, I want you to just look at your phone for a second. Think about the physical journey, the miles of ultra-pure glass fiber optics, and the massive machines tirelessly working behind the scenes right now to make your digital life possible. The internet might seem like invisible magic, but its foundation is unmistakably physical. So the next time you ask an AI a question or stream a video, ask yourself, where exactly on Earth is that digital action physically taking place? Somewhere out there, hidden behind secure walls, thousands of machines are working together just for you. Thanks so much for joining me, and stay curious.